I'm sorry for this interruption. I don't know what happened. All of a sudden I saw error here. So remember this formula for displacement inside one element, which I colored yellow. I also said using this similar formula, we can find any x or position inside. So the global one. So I can rewrite another formula, x equal n1 times x1 plus n2 times x2. x1 and x2 are global position of left and right side nodes. So you can find any x inside that element. Okay, this is a good one. Now it's time to go calculate strain. Strain formula is du dx. And we just find out that u can be written as n times the small u. And remember, the vector small u are the values for displacement at the left and right side nodes. So if I want to find derivative and expand this derivative, let's expand this derivative. It is going to be it is going to be u derivative of n over x plus n derivative of u over x. And I told you this is 0 because that small u vector is the values for left side and right side displacement. So they don't change by x, so 0 there. So basically, this is going to be, I don't know why I'm writing u all the time, vector u, which is the displacement value for left and right side, times derivative of nx. And we know n formula was a function of eta, not x. That is why we need to change the that x to eta. How I'm going to do that? Let me show you. So we said du dx. I'm going to rewrite this du d eta times d eta dx. Exactly same. Which is going to be d eta dx times dn over d eta times u. I just show you here. Okay, great. And I defined Jacobian name for you. The gradient of global coordinate with respect to the local coordinate, we call it Jacobian. So this one is local to global. It's not global to local. So basically, this is going to be reverse Jacobian. And I said, because we always prefer one matrix, one vector multiplication, so we call the whole piece matrix B, or strain displacement matrix. So based on this new definitions, it is epsilon or strain is going to be matrix B times vector U, and again I'm repeating, U was displacement on the left and right side nodes. Let's find a value for B. So I'm going to calculate this. Let's calculate on the right side. Change the color to gray to differentiate with our calculation, other calculation. du d eta let's start like this. So I said epsilon is going to be du d eta times d eta dx. So let's find the first one, du d psi. I'm calling this psi eta sometimes, sorry, which is going to be d psi. U is n1 times u1 plus n2 u2, which is going to be d psi. N1 was 1 minus psi divided by 2 times u1 plus 1 plus psi divided by 2 u2. So if I find derivative of eta, it is going to be, this one is going to be -1, this one is going to be +1, so it is going to be u2 minus u1 divided by 2. Done. Let's check d psi over dx. What was the formula for psi? Let's check it. Psi formula is this one. So I'm rewriting that formula here. So it was 2 divided by x2 minus x1 times x minus x1 minus 1. If I find this derivative over x, it is going to be 2 divided by x2 minus x1, which is equal to 2 divided by lengths of element, x2 minus x1. Let's see what is x2 minus x1. x2 is this one, x1 is this one. So basically x2 minus x1 is going to be this distance, which we call it LE, or length of that element. Okay, let's continue our calculation. So I found the first piece and the second piece. Let's multiply to each other and get strain. So strain is going to be u2 minus u1 divided by 2 times 2 over lengths of that element. So it is going to be u2 minus u1 divided by lengths of element. I'm rewriting this epsilon. Let's see. I'm rewriting as 1 over LE minus u1 plus u2. So I can rewrite this as this matrix formula. Minus 1, 1 times u1, u2. If you remember from here, this is equal strain. Strain is matrix B times U. Let's see what we found here. This is our matrix B and vector U. Therefore, our matrix B is going to be minus 1, 1, or unit matrix divided by length of element. Okay. All these calculations was for linear case when we had just 2 points, left and right side. Then I introduced another shape and I called it quadratic shape function. And I gave you a formula to extract this quadratic shape function. And the formula was that shape function I, which is in local coordinate or normalized coordinate, is going to be multiplication of these terms. J must not equal I. Psi minus psi j divided by psi I minus psi j. And we practiced that one and we got these formulas for quadratic one. Psi minus 1 divided by 2 for n1. n2 was 1 plus psi, 1 minus psi, and n3 is psi plus 1 divided by 2. And as you can see, quadratic shape function has 3 points. So you need to have 3 displacement value u1, u2, u3 to be able to solve this one. And let me draw like the previous linear one, the graph for n and psi. So this is going to be psi